Hey guys, so today we're going to do order of operations. This is something you guys have done in the past, but remember, order of operations is a way that we solve for an expression or an equation, so we're going to use that. Now, order of operations, we use this term PEMDAS, or you may have heard GEMS, but I'm going to use PEMDAS. Now, PEMDAS means parentheses. Remember, a parenthesis looks like this. Okay? Exponents, so it's going to be like x squared, so that squared is the exponent. Multiplication, 2 times 1 is an example. Division, let's do 2 divided by 2. Okay? Addition, we're just adding, so like 1 plus 1. And subtraction, again, let's just do 2 minus 2, so subtracted. One thing to note is multiplication and division, when you see that, you go in the order that you see it. So if division comes first, that's okay. That's just like one of those weird things when it comes to that. Same thing with addition or subtraction. You go in the order that you see it in. You're going to see that in a couple examples. We're going to do 3 examples together, and I'm going to cover one of these up so we can just focus on one at a time. Now, if we look at this example, sorry, I'm just trying to, there we go, is we have parentheses 17 minus 6 divided by 2, close parenthesis, plus 4 times 3. Now, I already wrote PEMDAS up here, and I suggest you do that on every single piece of paper that you see. You could either write it above it or below it and then rewrite the equation. I'm going to do both so you can see it, you can get used to it. Now, looking at this is, again, P means parentheses. So I'm going to scan this problem, and I see a parenthesis right here. So that means I have to do what's in the parenthesis first. But there's a lot going on in this parenthesis. I have 17 minus 6, and then I have a division sign, so I'm going to divide it by 2. But if I look in this order, I have parentheses, exponents, multiplication, division. Well, division's right here, but I didn't see any of this in there. So I'm going to divide first. So I'm going to take 6 divided by 2. Now 6 divided by 2 is 3. And I'm going to rewrite the rest of the problem the way that I see it. So I'm going to have 17 minus 3 plus 4 times 3. Now if I look at this, I have a whole new problem essentially because I have the parenthesis 17 minus 3 parenthesis plus 4 times 3. So I'm going to keep working in this parenthesis, and I only have subtraction, which is really nice because 17 minus 3 is 14. You can keep the parenthesis at this point, or you can drop it because we've completed everything in there. I'm going to drop it because it's not needed because I only have 14 by itself. But I still have 14 plus 4 times 3. So I have an addition and I have multiplication. But if we look here, multiplication comes first, which means I'm going to multiply 4 times 3, which is 12. And I'm going to rewrite everything else. So I have 14 plus 12. That's all that's left. Well, 14 plus 12, this equals 26. Okay, so you're breaking this down piece by piece by piece. I suggest using different colors for different steps, like for multiplication and division and addition and all that. You don't have to. I just like to. So again, I can kind of see how I broke it down, and if I made a mistake, then I can go back and be like, oh, this should have been, blue instead of pink. That just helps because as we get higher in math, we're going to have a lot more complicated problems where PEMDAS does come in handy, okay? So let's go to example 2. I'm going to cover that up. Now example 2 is I have parenthesis 18 divided by 6 times 5, close parenthesis, minus 14 divided by 7. Wow, that's a lot in the problem. I wrote PEMDAS, so I'm going to use that to help me. Now again, PEMDAS is parentheses, exponents, multiplication, division, addition, subtraction. Well, I see a parenthesis right off the bat. And in this parenthesis, I have division and multiplication. And like I said earlier, is you kind of do what's first. So I see division first, so I'm going to take 18 divided by 6, which is 3. And then I rewrite the problem the exact same way that I see it. So times by 5 Make sure you still have those parentheses. They are extremely important. Keep that in mind. So 3 times 5 in parentheses minus 14 divided by 7. I still have this parenthesis here, and remember that's really important to take care of. But what's really nice is it's just multiplication. So 3 times 5 is 15. And I'm going to rewrite minus 14 divided by 7. Now I have minus and division, okay? And I'm going to use my PEMDAS because I don't remember what comes first. So this is parenthesis, exponent, multiplication. Oop, division. Division came first. So I'm going to do 14 divided by 7, which is 2. So I'm going to have 15 minus 2. Well, 15 minus 2 is 13. And that's my answer. Okay, so again, that PEMDAS is just helping you to keep it in order because there's a lot going on. So you're breaking it down piece by piece by piece. Okay, we're going to do one more example and then we're going to move on to expressions. Okay, so example 3. Now here we just have the problem. So I have 10 minus 8 divided by 4 plus parentheses 7 minus 2. I don't have PEMDAS written here above like I did in the past 2 problems. So I'm actually going to write it below it, and I'm going to use the same colors that I've been using just to be consistent. Okay, so now we have multiplication, division, addition, and subtraction. All right, so I have PEMDAS written. I'm going to rewrite the problem below it, and I just like it above it. You could write it on the side, but I like it above it, and I'm rewriting the problem just so I can kind of get a grasp of it again. This is something we typically do in like a test or a quiz. If it's typed, then we'll rewrite it so it's in our own handwriting. So I'm going to scan the problem, and I'm going to see if it has a parenthesis in it. Nope, 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 yep, right here. So in the parentheses, we have 7 minus 2. Well, 7 minus 2, 5. Not too bad. So I'm going to have 10 minus 8 divided by 4 plus 5. Oh, I left some space. That's okay. So now I have 10 minus 8 divided by 4 plus 5. Well, what comes first? Subtraction, addition, or division? That's parentheses. That's exponents. Multiplication. Oop, division comes first. So I'm going to take 8 divided by 4, which is 2. And I'm going to have 10 minus 2 plus that 5. Now this is where it's kind of weird because it's like, oh, well, I have subtraction and addition. So you're going to do what's first. Here comes subtraction. 10 minus 2, 8. But I still got to tack on that plus 5. I haven't done anything with it. Well, 8 plus 5 is 13. Okay, so just keep it in that order. Keep it nice and simple. Now we're going to move on to expressions. I'm going to cover this up a little bit. Now basically what an expression is you'll have a word problem and it'll say write an expression just because we want to see what it would look like. We're not asking you to solve it. We're just asking you to write an expression, write it out so you can visually see it. And what it means is an expression doesn't have an equal sign. There's no equal sign. So I just wrote an example what it looked like. So like one example is 3a plus 6y. No equal sign. There's a 3a and a 6y. You can't combine it. You can't simplify it any further. It is what it is. Example 2, 3x plus 2. You can't combine any like terms. There is no equal sign, so we leave it like that. But we typically use it for word problems, so I do have some word problems. I'm going to go over how we should solve these just to make it a little bit easier, because I know word problems are not everyone's favorites. Okay, so I'm going to cover some stuff up just so we see the word problem. And then I'm going to move you guys up just a little bit. Okay, so you can see most of the word problem. All right, So I'm going to read it first, and then I'm going to go back and underline important aspects to this, and then we'll write the expression. So Sarah is purchasing tickets to the ballet. Each ticket costs $35 with a $2 processing fee. If X represents the number of tickets, write a variable expression to determine the total cost for purchasing tickets. So they actually gave us a lot of information right there. So let's break it down, and we're going to do it sentence by sentence. Sarah is purchasing tickets to the ballet. Nothing really important to underline there, just kind of telling us where she's going, so that's nice to know. Each ticket costs $35. Yeah, that's important. We need to know how much a ticket costs. With a $2 processing fee. Okay? So, with each ticket, there's an additional $2 cost. If X represents the number of tickets, I'm going to underline that. Write a variable expression to determine the total cost for purchasing tickets. It says expression. I'm going to write no equal sign. And I'm also going to write, because it told us what X is, I'm going to say that X equals number of tickets. All right? X equals number of tickets. I'm going to go back to what I underlined because I already took care of this besides the expression. So I just need to keep in my mind no equal sign. Each ticket costs $35. So I'm going to write 35. And each ticket, there's a $2 processing fee. So additionally to the $35, you're going to pay another $2. So I'm going to write plus 2. Now, the only thing we're missing is this X, because it does tell us in our expression we need an X. But what does X represent? Well, I wrote it right here. X is the number of tickets. Okay. 2 is the processing fee, but 35 is the ticket cost. So I'm going to write X, because I don't know how many tickets she's buying. So I'm going to have 35X plus 2. Since it's an expression, no equal sign, I'm done. Okay, we're going to do another one. We're going to do it the exact same way. We're going to read it, we're going to underline, and then we'll write it out. Okay. Actually, I'm going to keep this right here so we have a white background. Sorry, shaking the camera. Okay, so example 4. The water level in the bathtub when full is 36 inches. When the plug is pulled, the water flows down the drain at a rate of 6 inches per minute. Write an expression that represents the water level n minutes when empty. Okay. I'm sorry, I'm just picking out a color to use. Okay. Now we're going to do it sentence by sentence like we did before. When the water level in the bathtub when full, or the water level in the bathtub when full is 36 inches. Well, the only thing that's important, 36 inches, when full. When the plug is pulled, the water flows down the drain at a rate of 6 inches per minute. Now it's flowing down the drain at 6 inches per minute. So if it's going down, it's getting smaller, it's decreasing. So I'm going to write a minus. Because when you drain the tub, you're losing water, you're not gaining water. So you're going to subtract. Write an expression, no equal sign, that represents the water level n minutes when empty. I'm going to write, it says use n, so n is the minutes when empty. Okay. Well, it says it starts out at 36 inches. I'm going to have a 36. And the water drains at 6 inches per minute. Now remember, I wrote that minus sign because drains means I'm going to lose. Not gain, lose. So I'm going to have minus 6. But n is saying, well, that's the number of minutes until it's empty. 36 is just saying when the bathtub is full, where 6 is saying every minute you're going to lose 6 inches. So I'm going to tag it on with this 6. So then my expression is 36 minus I. Okay, so again, expressions don't have equal signs where equations do. And always use order of operations when solving an equation.